assignment start with the relational algebra question where we are asked about a new operation, that is the division operation. Division operation is a bit complicated. I like to think it as opposite of Cartesian product, and its formal definition is when relation 1 is divided by relation 2, tuples of relation 1 associated with all tuples of relation 2 are returned when we do this query. That is, the tuples that are returned cross product with relation 2 should give us relation 1, just like a normal division. So in this case we will start from solving inside the bracket, where the first bracket has selecting 3 tuples that are marked in different color than black, where the amount is greater than or equal to 2000, and the modes are UPI and card. And in the second query, where the transaction ID is 4, card is selected. Hence, when we subtract from UPI card minus card, we only get UPI, UPI. And when we do that when we divide this whole relation with R2, where there's only these two, UPI is returned. Moving on to question 2. Again, question 2 is based on relational algebra expressions. We are given two relations, and this highlighted expression is common for both of this, where the amount is greater than 5000 in the payments, that is this one schema, is cross producted with payment by, that is all the tuples in payment by. So there will be total 6 tuples resulting from this highlighted part, and the trick is over here, where we are projecting from payment by in the relation R1, which will contain all the 6 tuples, and in R2 only payments which will contain only one tuple. Now we are asked which of the transaction will not be present in R1 minus R2. R1 minus R2 is nothing but this payment by, that is all the tuples, minus common tuples R1 intersection R2, that is the 15 wala tuple. Hence all minus 15 will be the result, that is 15 will not be present in the output. Moving on to question number 3. After relational algebra, there are two types of calculus, that is tuple relational calculus and domain relational calculus. Yes, the calculus is here as well. So the statement has to be converted into tuple relational calculus. Remember that in tuple relational calculus, the square brackets won't be there. They are part of domain relational calculus syntax. Hence option B and D are already eliminated. Now from the statement, display the titles of the videos that are published on YouTube channels and have more than 50,000 likes. From A and C, the correct syntax is this one, where we don't have brackets for YouTube, or because YouTube is a string literal. Hence C is the correct answer. Moving on to question number 4. Here we have domain relational calculus. As I said, the square brackets must be present at the start of the relation specification, that is inside curly braces. Hence option B and D are eliminated beforehand. Now let's read the query. Select channel video title from content where dislikes are less than 100. There are two types of quantifiers, that is, this is the exists and this is for all, just like mathematics. Now this one, A1, will translate as C comma V, the exist domain relation C comma V, where L comma D and all of these attributes belongs to content, and D, that is dislikes, are less than 100. Out of A and C, A has the correct syntax, that it uses those brackets, hence A is the correct answer. Question number 5 comes from embedded SQL, that is when we run SQL inside of some other language, whether it be C, Java, Python, they have their own libraries. In C, we declare a cursor first and then do some sort of query. Now here we are asked that from the payment schema, select the SQL query returns transaction ID and amount of those payments from payments whose payment date match with the user's entered date and amount is more than the entered amount. So for this, to get users input, we need variables, and when we use variables in SQL, we need the colon as the syntax. In all of the options, B and C don't have colon, they're eliminated. Out of A and D, D doesn't have the correct use because payment date and amount are attributes, they are not variables. Moving on to sixth question, we see that we have given a schema clothes where each cloth item is identified by the tag, that is it is a primary key, and those also have sizes and materials, they are not the primary. However, each cloth can be designed by multiple designers, that means that it is a multi-valued attribute. Hence, we have to identify the schema and entity set. Entity set is basically a set that tells us all of the attributes associated with an entity. Here, clothes is an entity and designer is also an entity. Now, the attributes like designer, which are multi-valued, should be placed in a separate schema. It is a good design practice, and each cloth will be definitely be associated with the designer. Hence, the option D is correct. So question number 7 is on ER diagram, where we are given 3 schemas, out of which the 2 succeeding schemas inherit, that is they have common properties, attributes from the first schema, story schema. The correct inheritance is option number B, where the attributes are inherited, which is a good design practice. Hence, the redundancy is reduced. Moving on to question number 8. Now we are given a ER diagram which has this double line, and single lines. Double lines tells us that the schema on the double lines edge must occur in the relation, and this is partial, that is it may or may not occur. That is, this whole thing is interpreted as each conference must have an organizer, but every organizer may or may not organize a conference. Hence, we are asked which of the following are true. The participation of organization is must, that is it is called a full participation, and conference has partial participation. Hence, B option is correct. And when we have an attribute inside curly braces, then it is called a multi-valued attribute, and if presenter was supposed to be a composite attribute, then its sub attributes will be intended in the schema. The same ER diagram is given again. This time we have to find the correct schema for books, and since book is a relationship between many to many schema which has entities, books must contain only the primary keys from its participation entities, since that is sufficient to identify each tuple in the relation. Hence, option number B is correct. Question. This question is also based on relational algebra. Here we are given an algebraic expression and a schema, organizer schema, which has 3 attributes. This symbol denoted by 2 angled brackets is called as not equal to operator, that is x name should not be equal to y name, and both of the brackets which are highlighted are just self Cartesian product of organizer with itself, that is 4 tuples times 4 tuples will give us 16 tuples. We are supposed to do intersection of these two, where in the second one x dot research domain equal to y dot research domain. So when you think about the first selection, you can imagine that only the tuples will match with themselves, since the name, all of the names are unique. Hence, first tuple will match with some other tuple that have the same name, Matthew, that will be eliminated. Each time with each tuple, one tuple will be removed. Hence, 4 tuples from 16 tuples will be removed. So the first pair will have 12 tuples. In the second selection, we have to select the domains where x dot research domain equal to y dot research domain, and research domain are not unique. Hence, mind that they consider the duplicates. Hence, each tuple will contain at least 3 entries associated with them, but they will also contain the extra entry. You might want to work this out and solve the relations for each selection, and you will find out the research domain will have 6 tuple. This second selection will return 6 tuples, and finally when you intersect them, you will find that there are only 2 tuples where the x name is not equal to y name and x dot research domain equal to y dot research domain. As always, thanks for watching, and keep liking the videos, subscribe and comments if there are any doubts. See you in the next one.